Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on calculus of variations, lecture number 3, in which I will solve some problems on Euler's condition. Now, we solve a problem. Problem is solve Euler's equation for the function f equal to 1 by y square root 1 plus y prime square, and so that the general solution is a two-parameter family of circles with center on x-axis. Now we solve this. Since given that f equal to 1 by y square root 1 plus y prime square. Therefore, f is the function of y prime. This is number 1. This is number 2. Here we see that f does not contain x explicitly. Therefore, Euler's condition for extremum value of the integral is f equal to c plus y prime partial derivative of f with respect to y prime. This is number 3. Implies that f minus y prime partial derivative of f with respect to y prime equal to c. This is number 4. Now, differentiating 1 partially with respect to y prime, we get partial derivative of f with respect to y prime equal to 1 by y multiply 1 by 2 square root 1 plus y prime square multiply derivative of y prime square 2y prime. This equal to y prime by y square root 1 plus y prime square. That this is number 5. Using 1 and 5 in 4, we get value of f is 1 by y square root 1 plus y prime square minus y prime partial derivative of f with respect to y prime is this y prime by y multiply square root 1 plus y prime square. This is c. Implies that we take common 1 by y square root 1 plus y prime square minus y prime square by 1 plus y prime square square root. This equal to c. Implies that 1 by y, here LCM 1 plus y prime square square root, here 1 plus y prime square minus y prime square. This equal to C. Implies that 1 by y, here y prime square and y prime square cancel out, remains only 1 by square root 1 plus y prime square equal to C. Implies that 1 by cy equal to square root 1 plus y prime square. Implies that 1 by c square y square equal to 1 plus y prime square, squaring both sides. Implies that 1 by c square y square minus 1 equal to y prime square. Implies that 1 minus c square y square by c square y square equal to y prime square. Implies that square root, taking square root both sides, 1 minus c square y square by cy equal to y prime. Implies that square root 1 minus c square y square by cy equal to dy by dx. Implies that dx equal to cy by square root 1 minus c square y square dy. Let this is number 6. Let cy equal to sin theta. Implies that c dy equal to differentiation of sin theta is cos theta d theta. Let this is number 7, this is number 8. Using 7 and 8 in right side of 6, we get cy by square root 1 minus c square y square dy equal to cy means sin theta and dy means 1 by c cos theta d theta, and this is 1 minus cy means sin theta sin square theta square root. This equal to 1 by c sin theta cos theta by 1 minus sin square theta equal to cos square theta and square root is cos theta d theta, and this equal to 1 by c cos theta cancel sin theta d theta. Let this is number 9. Using 9 in 6 and then integrating, we get integration dx. This equal to 1 by c integration sin theta d theta. Implies that x plus c1, let c1 be the constant of integration, 1 by c integration of sin theta is minus cos theta. Implies that x plus c1 whole square equal to 1 by c square cos square theta, and this equal to 1 by c square cos square theta equal to 1 minus sin square theta, and this will be equal to 1 by c square 1 minus sin theta is cy, c square y square, and this will be equal to 1 by c square minus y square, implies that x plus c1 whole square plus y square equal to 1 by c square, implies that x plus c1 whole square plus y minus 0 whole square equal to, let this is c2 square, let 1 by c square equal to c2 square. This is number 10. The equation 10 contains two parameters c1 and c2. Also, equation 10 is an equation of a circle whose center is minus c1 0, that is on x-axis. Let this is 11 and this is 12. From the statements, (11) and 12, we conclude that equation 10 represents two parameter family of circles such that centers minus c1 0 lie on x-axis. Proved. Now we solve the next problem. Problem is obtain the Euler's equation for the integral I equal to integration limit a to b py square plus 2qy y prime plus ry prime square dx, where p, q, r are functions of x. Now we solve this. Solution, given that here f, this is f equal to p y square plus 2q y prime plus ry prime square. Let this is number 1. Also given that p, q, r are functions of x. Therefore, p is the function of x, q is the function of x, and r is the function of x. Therefore, from 1 and 2, we get f is the function of x, y, y prime. Let this is number 3. Therefore, Euler's condition for extremum value of I is partial derivative of f with respect to y minus d by dx, partial derivative of f with respect to y prime equal to 0. Let this is number 4. From 1, partial derivative of f with respect to y equal to, here p is the function of x, so it will be treated as constant when partially derivative with respect to y. So this will be p multiplied 2y plus, similarly here 2q, this will give the result 1, partial derivative with respect to y and remains y prime. So this will be 2py plus 2qy prime. Let this is number 5. Now partial derivative of f with respect to y prime, here this will be 0 and this will give 2qy and plus r multiplied 2y prime. This will be equal to 2qy plus 2r y prime, implies that d by dx, partial derivative of f with respect to y prime, here 2q is the function of x, so firstly we differentiate this, q prime, y remains constant, plus 2q, we differentiate y with respect to x, this is y prime, plus 2r is the function of x, so differentiation will be r prime y prime plus 2r y double prime. Let this is number 6. Using 5 and 6 in 4, we get 2py plus 2qy prime minus 2q prime y minus 2qy prime plus, not minus, 2r prime y prime minus 2r y double prime equal to 0, implies that qy prime, here qy prime cancel out, dividing both sides by 2, we get py minus q prime y minus r prime y prime minus r y double prime equal to 0. This is number 7 and this is the required result. Now we solve the next problem. Problem is, prove that the shortest distance between 2 points in a plane is a straight line, or prove that the geodesics on a plane are straight lines. Now we solve this. Let A be a point whose coordinates be x0, y0, and B be another point whose coordinates be x1, y1, be two fixed points in xy plane. Let us join AB by an arc here, by this arc whose length is S. Let PQ, this is elementary arc DS, PQ equal to DS, elementary arc of the curve, where coordinates of P and Q be xy and x plus dx comma y plus dy respectively. Since ds square equal to dx square plus dy square, dividing both sides by dx square, we get ds by dx whole square equal to 1 plus dy by dx whole square. Taking square root, here ds by dx, here is square root of 1 plus dy by dx is y prime square here. Implies that ds equal to this multiply dx integrating from a to b, means taking the x coordinate x0 to x1 ds integrating. This side also same limit integration x0 to x1, and this value is s, means sum of all elementary arc integration means, that is s. And in right side, let this is function of y prime, here only y prime we get, no x, no y, where this equal to f y prime. This is number 1, this is number 2. The Euler's condition for extremum value of the integral s be partial derivative of f with respect to y minus d by dx, partial derivative of f with respect to y prime, this equal to 0. Since f does not contain x and y explicitly, therefore this condition reduces to partial derivative of f with respect to y prime equal to constant equal to m1. Let implies that here fy prime is square root 1 plus y prime square. If we differentiate this, we get 1 by 2 square root 1 plus y prime square multiply 2y prime equal to m1. 2 cancel, implies that y prime by 1 plus y prime square root equal to m1. Squaring both sides, we get y prime square by 1 plus y prime square, this equal to m1 square. Implies that 1 plus y prime square by y prime square equal to 1 by m1 square. Implies that 1 by y prime square plus 1 equal to 1 by m1 square. Implies that 1 by y prime square equal to 1 by m1 square minus 1 implies that 1 by y prime square equal to, let this is m2 square. Let 1 by m1 square minus 1 equal to m2 square implies that y prime square equal to 1 by m2 square implies that y prime equal to 1 by m2. Let this is equal to m. Let 1 by m2 equal to m implies that dy by dx equal to m implies that dy equal to m dx. Integrating, we get integration dy equal to integration m dx implies that y equal to mx plus constant c, where c is a constant of integration. This equation represents a straight line. Therefore, the shortest distance on a plane is a straight line, or in other words, geodesic on a plane are straight lines. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.